Hello, welcome to the latest episode of Data Unchained. I'm your host, Molly Presley. Let me tell you just a little bit about this podcast before I introduce today's guest. Data Unchained was created around the concept of, if you think about how data has been created since the advent of maybe some of the first computers from IBM, that really the architectures were designed for people to have the applications all local to the computer. And yet, as the advent of the cloud came about, lots of sensors, IoT, distributed data sets even coming from space, it's become really interesting to be able to have access to data created anywhere with the compute and the applications that may not be residing local to it. So Data Unchained digs into the problems, some of the solutions and best practices around using this distributed data with the applications and compute environments you most desire. A great guest today is Desiree Campbell from the Azure team over at Microsoft. Desiree is the managing director for HPC Americas and certainly has great insights into the technologies that are available, as well as how some of the bigger cloud companies are going about getting the data into their compute environments. So Desiree, thank you for joining.
Thank you for having me, Molly.
Before we talk about technology and Azure, tell us a little bit about yourself. What's your background? How did you end out in, a pretty, I would say, important role over at Azure in the HPC side? I think that's a bit unusual for some women. Maybe just tell us a little bit about your background.
Absolutely. I started off as a scientist, a geologist and a hydrogeologist working for the Environmental Protection Agency. And I did things that required supercomputing, Monte Carlo analysis, for instance, to determine what the risks were to human health, toxicology analysis. And I went from there and worked in various tech companies, big, small, consulting, government, but I always gravitated towards computational science and went from the end user side of it, being the scientist, to helping manage the infrastructure. So I managed teams of scientists, computational scientists at first CDC, doing really cool bioinformatics work, and then managed teams of scientists working for ARL and NRL. And both of those were as government contractors. I wasn't working for the government at that time. Everything for the compute at that point was on premises, and the government was one of the few places that had these massive supercomputers that could run the equations that were needed to do all of the fascinating stuff that scientists have to do to keep us moving forward. As I progressed further and worked for a bunch of big tech companies, I kept coming back to high-performance computing and to artificial intelligence, deep data analytics, doing a lot of work for the government. And it all culminated in a really interesting job offer here at Microsoft Azure to get involved with running the team for the Americas to lead the HPC business. And when I first started, it was HPC plus AI, and we had all the AI infrastructure and did a lot of AI workloads. But as Microsoft has, over the past few years, become one of the leaders of AI, we split off, and there's an entire team doing first-party AI workloads. And my team is back to focusing much more on HPC. But as you know, HPC and AI are often in the same algorithms and problems that people are trying to solve, whether AI is creating the data that the HPC algorithms are solving. So I'm not very far from AI. I just don't have it in my title anymore. And it's been the dream job for me, because it's a combination of tactically, we help our customers figure out how to use Azure in the cloud. Typically, they're simply on-prem, and so they don't know how to do this in the cloud. And we work with them on proofs of concept and figuring out all of the technical things and benchmarking and what will make them work for performance, why they should move into the cloud, a business case or not. And for that part of the business, I'm responsible for our financial targets for the Americas, for Azure revenue associated with high-performance computing. But then the part that I especially love is I work with the field sellers and with the partners and with the customers themselves and help determine the gaps what they're needing and what we already can solve and what we can't. We can turn to partners and try to come up with really tight, cohesive solutions, or work with our product group to give them that feedback so that they can come out with new solutions, especially for HPC. And because of that, both strategic role as well as the tactical piece, it's really just a dream job.
It sounds amazing. I'm curious. So the journey to the cloud in HPC has been interesting, as you worked with a lot of the agencies and HPC institutes in the data center. I'm sure you've experienced similar, that everything was built around those supercomputers, and then the cloud came in, and there was a lot of thinking about how do we integrate this into our workflow? How do we maintain performance? Those types of things. Could you maybe just share with us, where do you see the cloud being used in HPC primarily right now? Is it storage? Is it compute? Is it hybrid? Maybe just tell us kind of from your experience there at Azure, how folks are deploying. How is the cloud being used?
Absolutely. The first thing that people dabble with, say they're already on premises with either a supercomputer or just really powerful data centers and parallel processing, the first place they usually go to is simply compute in the cloud. And we work with them, and typically they're blown away if they don't have a supercomputer by how powerful this is. The performance is what sells them. And the ability to do things as much as 50, even 100 times faster certainly overcomes any other qualms they have about cost, about security. Security was really raised as an issue for a while. I think folks are starting to realize that a major cloud service provider is possibly quite more secure than what they're doing already. We have a lot built in. So the compute is the first place people start, and some places stop there. So if you imagine that you are you have access to a supercomputer, your own or one of the government ones, very often you can't get the time you want if you aren't the top of the list in terms of the algorithms that you need to run. So even organizations with supercomputers use us for bursting into the cloud when they don't have the ability, or for jobs that can't get the premier space on the supercomputer. And so that'll be for compute. Then for organizations that never had access to a supercomputer, I'm thinking of some universities, a lot of medical institutions, some engineering institutions, by which I mean corporations. They will often move their storage into the cloud as well, especially as they want to start working with AI. They find it's easier to have the data and the compute, everything in one place. But the first place that folks start is usually just bursting into the cloud for compute, then possibly moving into storage. I would say that our largest customers, though, are absolutely in a hybrid scenario. They have on-prem and they have cloud. They may have more than one cloud service provider, and they do a mix depending upon what they're trying to accomplish of storage in the cloud, compute in the cloud, storage on-prem, moving it between a supercomputer for compute, moving it then to a cloud. And it's very much a hybrid world, which creates a lot of interesting challenges to help orchestrate it.
And you mentioned before we kicked off the call today that there's some new capabilities that you have, new instances in the cloud related to continually optimizing the types of processors you have. Let's talk about that a little bit and just kind of the release cadence, because I think what you say is really interesting, that coming from the HPC world, usually those budgets were every 3 to 5 years you build out a new compute environment, and then you were kind of stuck with that. And yet in the cloud, you have the ability to introduce new options for compute environments at a much faster cadence. Maybe talk about what's new and kind of how often are you releasing new types of compute? How do you decide which types of compute to offer?
Absolutely. So you really hit upon one of the things that drives customers to us, whether they have access to a supercomputer or not. If you think about sourcing in the day, definitely a cray, it would take a year or more for the acquisition process, and then you would probably competitively award it, and then it'd have to be built, and you're already 2 years in. Then it'd have to be delivered and tested, and you're 2.5 to 3 years in if there's any delays. And what you came up with your requirements is already years old. Then you're going to use this for 3 to 5 years, probably 4 to 5 years, and somewhere in the process of using it, you're going to come up with a new acquisition and what you need. Azure releases new capabilities absolutely every year, sometimes much more frequently. It really depends upon what our major partners are doing with the new capabilities that they're releasing. And most folks probably know that a year ago at Ignite, which is at the same time as Supercomputing, Microsoft announced that we're going into the hardware space. So we are releasing our own hardware and VMs for HPC and for AI. And Molly, I think you're referring to the fact that we've just released the Azure NV V710s for real-time AI ML inferencing and advanced visualization in the cloud. And this is going to be great for things like VDI, visualization, cloud gaming workloads, small to medium inferencing workloads for AI ML. And that's one of the things that our customers can use. The other thing that we've just released are the NMATs, MA35D. These are media processing VMs, and it's going to allow scalability, efficiency, and performance for anybody who's trying to process media workloads, ultra low latency, and incredible cost efficiency. And one of the benefits of going to the cloud, even if you keep things on-prem as well for sometimes compute and sometimes storage, is that as these are released, you can immediately access them. And you can even access them before release because we have private preview and public preview. But definitely once things are GA, you don't have to wait that 3 to 5 year refresh cycle that you have on your hardware.
So speed is not just about speed of running the job and getting the compute time, but speed of getting access to new infrastructure or technology. I think it's really interesting, and will innovate in how results can be produced and how quickly on a much faster basis. And that's awesome. So when you talk about hybrid environments, when you think about the orchestration side, orchestrating the workflow, the job scheduler, picking which compute to run on, moving the data, do you all get involved in recommending how to go about that from your group and the HPC team, or how do you approach that?
Yeah, so that's specifically what my team does.
Okay.
The salespeople out in the field have their customers, and they identify that customers might be interested in doing workloads in the cloud. The engineering group, of course, keeps coming up with great software for scheduling and now hardware for the VMs, but also just building our clusters in the cloud, which we were so proud last year to be in the top 3 of cloud compute for performance. It's beating almost all the supercomputers in the world. It's really impressive what we're doing in the cloud. But HPC is complex, and it's not a wash, rinse, repeat, and everybody just goes to the same architecture. So it's my team who works with the customers to determine what's the right hardware, what's the right for both storage and for compute, what's right networking, what's right security, how are we going to move the data into the cloud, and who will do proofs of concept with them to enable them to make that business case internally that this is how they want to go. And we look at first party first, always, just to see if we have the right tools on the truck, and then we turn to our trusted partners to fill in any gaps depending upon the scenario. It's really different for each industry vertical. So my team is specialized by industry vertical because what the banking industry needs versus media and entertainment versus, say, government with climate research. The size of the data, the latency that they can tolerate or not tolerate, the performance that they have to have, the security requirements, it's different and very specialized.
So Desiree, as you think about architecting these workflows with your customers, can you give us some examples of how you work with your customers to both identify their needs of their on-prem, their cloud space, and how you design their architecture and their orchestration across these hybrid environments?
Absolutely. And, I mentioned that my team is specialized in different industry verticals because each industry vertical, while architectures will be unique for each client. They have similar challenges that they're trying to solve. So for instance, in the energy industry, we often have double-digit petabytes of data. That's just massive amounts of data. And the ability to move that data around between different regions or from on-prem to the cloud becomes a real interesting problem to try to solve. So the focus in the energy industry really becomes around the data and how you get the data closest to the compute. And therefore we have to lean to, it's less about schedulers, it's more about making sure we architect in that they will probably want to use multiple regions for the specialized SKUs that they're offering and have infrastructure built in and perhaps pipes to more than one region. Because if you think about hybrid, you may have on-prem and you have cloud, but the next wave is you don't have one cloud, a cluster in the eastern U.S., you might also have a cluster in the south U.S. that you want to use in order to get access to some of the latest and greatest SKUs, latest and greatest VMs or capabilities. And building those more complex architectures that are going to allow data to flow not just from on-prem to cloud, but from cloud region to cloud region, maybe even from cloud region into the US to cloud regions overseas in EMEA or in Asia, is the next frontier of architecting for our clients when they have massive amounts of data like that. The government also has often extremely huge loads of data, and they're not going to put all of their data in the cloud. They want to do their compute in the cloud if they're bursting into it, but then they want to bring it back on premises to process it, to store it. So for industries like energy and the government, we have one type of issue that we're trying to solve, and we always turn to partners to help make that happen, whether it's storage partners or software partners. Then you go to different industries like media and entertainment. And for media and entertainment, what they do is they render the movies that we see. And we here have helped studios produce just amazing films with incredible graphics and animation. And the studios, they view their data as their gold intellectual property. So they're not going to put it in somebody's cloud and leaving it there. So they have completely different solutions that involve caching typically to get the data close to the cloud compute. And you need certain types of scenarios there. And that's one where we are actually exploring with Hammerspace future technology that will work even better for caching solutions. If you look at something like the financial services industry, which on a quarterly cyclical basis is running really large algorithms around risk or around closing things for the client or predicting things if they're in futures, they have absolutely different scenarios, and they're often doing wholesale migrations of everything into the cloud as it proves out. And so they have different types of scenarios where latency is different for them than it is for somebody who's sitting at a desktop and doing virtual visualization, and they have to have that almost zero latency because it's going back and forth. If you're just uploading a ton of data into the cloud and there's a read time, whatever it is, and then you're going to do Monte Carlo analysis on it for many, many multiples of how long it took to read it, it doesn't matter as much if the data is pretty far. So what we always do is we consider, whether first party or third party, we consider the wealth of schedulers out there. We consider all of the different storage environments, and we certainly have Microsoft storage, but very often we turn to partner storage because it's going to be the best for the client. And whether it's the hardware or the software or the orchestration, I said earlier that we look at first party. That's really because that's what we know best, and we have such a great amount of things in our toolbox. But we would never ask a client to use a Microsoft product because it's Microsoft. Microsoft goes to market with our partners, and we don't always have the skill sets in the partner technologies. We know about them, but then we partner up with their technical engineers to make it work for the customer.
I think that's great. And thank you for sharing examples across so many industries. On the media side, we have a joint customers, Jellyfish Studios or Jellyfish Pictures out in London. And as you think through the collaboration, no matter which industry you're in as a listener, it was really cool to see they're very innovative. Jellyfish tried to do something that, or has done, not just tried, but has done something that was really necessary in COVID, that they needed artists to be able to collaborate, even though they weren't in the studio. And then they had a completely different problem with their London data center, which they own, was out of compute cores, and they wanted to take on new projects. And the only way they could do that was if they were bursting to the clouds. And you think through in these kinds of industries where work getting done quickly and being able to be nimble and say, oh, I want to take on that project, but I need to be able to render the job and get it done in 30 days or whatever that time cadence is. It literally was the difference between being able to take on more work and grow as a company or not. And it was using cloud regions. In their perspective, they went for cloud regions in Canada because they're a little less expensive, because power is less expensive than it is in London. So it's interesting to me to see that there's a lot of variables on speed, money, capabilities, that being able to integrate these cloud workflows into your standard workflow in hybrid environments makes such a big difference for these companies. But it takes expertise, right? It takes architecture expertise to figure out all the little tools, and they exist. And so it's great to have a team like what Desiree is managing to help you with that.
Yes. Two things I'd love to add, sort of related to the jellyfish example that you brought up, and we'll put a link to that story in the show notes if people want to take a look at it. But the studios get tax breaks when they film around the world, and they want to have their rendering close to them. So my team helps work with these studios so that they can do rendering all over the world on location as they're trying to do their movies, and go from Canada to the US to London to other places. It's really exciting how we can help them get their work done quickly. But another example, which is one of my favorite ones to use, of like when my grandmother asked me what I do for a living, is we're worked with a client who is a children's research hospital, and they do cancer research. And they were doing their research on premises in an on-prem data center. And when they decided to try out bursting to the cloud and a proof of concept with my team, they realized that the research trials that they were doing, that were taking 100 days on average, could be completed in 1 to 2 days. And the beauty of doing something 50 to 100 times faster, even just 50 times faster, is that you can do that much more research. You don't have scientists sitting around waiting to see what fails so they can go on to something that doesn't fail. And you're going to really make a difference ultimately in the lives of children who have cancer. And that's something that this research hospital would not have been able to do. They don't own a supercomputer. So they were able to do something they couldn't do because of the beauty of the cloud. And that's the sort of thing that I think drives me every day to get up and figure out, okay, how am I going to work with my team, work with my partners, work with our field sellers to get to the clients to help them do incredible things that they've never done before.
Yeah, absolutely. And so I'm sure probably for our listeners who are Azure customers, they have account managers and they can ask for somebody in the HPC team. Is that the best way to get to your team if they're listening to this? And I mean, honestly, we all know that figuring out how to get access to compute is a problem pretty much all users are looking to solve right now. And whether it's because it's too expensive or it's not available enough or in the region they want, or, there's a lot of reasons why the struggle to get to compute is top of mind, it seems like, with almost all users. People with expertise on this are somewhat limited, and your team is experts in this. How do they get to your team?
Definitely they need to go through their account managers, Azure account managers. And the Azure account managers have checklists of basic information that they need to collect about the client's existing environment. and the types of workloads that they're running, or the type of open source or commercial software that they're using to run HPC. And once they gather that basic information and determine why the customer is interested in moving to the cloud, is it performance, is it cost, is it the ability to do something they've never been able to do on-prem, they want to explore AI and they've never been able to do that, then they'll pull in the right experts internally, and almost certainly somebody is going to reach out to my team. And we may pull in other experts as well, especially ones with deep AI experience, depending upon what the scenario is. And so just anybody listening, reach out to your Azure account manager if you're interested in exploring HPC and Azure Cloud.
And I know you said inconveniently to some degree, Ignite is at the same time as Supercomputing this year, and so you won't be at Supercomputing like you,
I'm afraid, not.
Otherwise would be. But so maybe we can talk just a little bit about the supercomputing industry. And you and I both have long roots there, and I'm on the board of Women in HPC. I know you have a lot of passion around the diversity in women in this industry and just in leadership in general. What has your path been like when you were in the end user space, maybe even at Azure as well? Have you found mentors that have really helped you? Have you run into obstacles that you'd like to share some of your experiences around?
Yes, I have not been as lucky as I like to find mentors to help me in this field. I sort of stumbled into it, but I would definitely say that I've recognized that lack of mentorship, and I try to mentor people. HPC, the reason there's organizations like Women in HPC is like STEM, but definitely even more so for HPC. If you go to an HPC conference, I'd be shocked if you see 10% of the people there are women. And it's often even less. And by the time you get folks who are more senior, you're starting to get into definitely single digits. There's more at the beginning of the funnel, which is great. And when I've had to interview and replace positions, I've been shocked at the dearth of highly qualified female candidates. It's not that they're not out there, they absolutely are, but there may be one for every 10 or 20 male candidates. The helping more women get into the fields of HPC, whether they're interested in the infrastructure side and creating the hardware and the software and the networking that allows it to happen, or whether they're the computational researchers who want to do things that require supercomputing. I believe that the more women we can get in there, the more different types of ideas we will have, and the better everything will be. It's not that women bring something more, it's that they bring something different. And anytime you only have one in any group of 10 be a woman, I think you're lacking that diversity. And I've been involved with helping women in STEM through Women in Technology or Women in Science and Engineering, and working my way up to leadership roles in organizations like that ever since I was in my early 20s. And I continue to be passionate about it.
So when you think about the career opportunity in HPC, I think about maybe 5 or 10 years ago, there was some concern around a lot of the population who knew how to build the applications, the infrastructure around HPC were kind of aging out. They were starting to retire, and the HPC industry was concerned about where is our next talent and the volume of candidates that we need. Do you feel like that has changed? Has AI and the focus on data analytics changed? Is this a great field to be investing your time in as you're looking at the options as a technologist?
It's an incredibly exciting and potentially very lucrative field. It's certainly very rewarding for those who like things that change at a pace of you're constantly learning and researching and studying, because a month goes by and so many different things have changed. So for anybody who is creative and passionate about learning and technically focused, I think that there's really no better field right now to go into than HPC and AI. It's extremely exciting, and there's so many different ways to contribute, whether working for big companies like Microsoft, a gazillion startups out there, and certainly the government and institutions, and whether it's manufacturing or engineering, finance, all of the industries are figuring out how to power supercomputing that's available now because of major cloud providers, public cloud providers, and to do things that were never possible. Just like AI started in the 70s, and maybe even really going back into the late 60s, and then they had the AI winter because there just wasn't the supercomputing available. And some government labs were doing different things around the world because they had supercomputers, but for the rest of the world, it burned out. It was overpromised and underdelivered. And it really wasn't until the last 5-7 years with cloud supercomputing available that AI has taken off like crazy, because now everybody can take advantage of it. And I think that there's no better field to go into. There are a lot of programs for HPC specifically for young people in universities that are sponsored by folks like the Department of Energy National Renewable Energy Lab, NREL, right here in Colorado, where you and I both live. And they're working with some historically underprivileged universities to help students stay in school, study the sciences, do internships at their labs. Perhaps there's scholarships or other things involved. There's a lot of organizations that do things like that. Microsoft does internships. And I think that to answer your question more specifically, I think that the front end of the funnel, the large end of the funnel, is not going to be a problem. I believe there's more of a challenge of people dropping out in the middle. And that's where I think we really need to focus on getting people to stay in the field and continuing to progress, at least the women and the minorities, because people talk about diversity and inclusion, and I think the focus is not often enough on what inclusion means. Inclusion means, to me, that, like when I went to university for chemical engineering, when you look around and there are 3 women in a class of 500 for these early science and engineering and lecture classes. A lot of people can't stand that pressure. They don't want to stick out like a sore thumb. And then you go through your first 10 years of a career and you look around and you're the only woman in meeting after meeting and conference after conference. And a lot of people drop out. They don't feel like they're surrounded by people who look or think like them. And as you try to work your way up the ladder and you realize it's the same thing, the glass ceiling is still there, and there aren't people who look like you or can relate to you with the specific challenges that you might have because of your gender or your background, it can become discouraging and people can drop out. It's not that they're not really good at what they're doing. It's not that they're really smart. It's just people often don't like being the only one.
So how do we help in that middle stage? Do you have suggestions as an industry or as leaders? I agree. That's a really interesting topic, the middle of the funnel. If you're in that middle of the funnel and making that decision, do you think we should help in pointing them to where they can find areas of community, or do you think it's more like the corporation's job to try to help with this? What is your thought there?
I think that it takes a village. And so I know that large corporations often have a very sincere emphasis on diversity and inclusion. And Microsoft has a commitment to D&I like no company I've ever been involved in. And they really want everybody mentoring, and they don't want you mentoring your closest buddy who works across the virtual hall from you. They want you mentoring somebody who is different than you, who is younger, who's a different generation, who's in a different country, who is maybe or maybe not in your same field, but who is significantly different enough from their outlook and their perspectives, their point of view, that you'll learn as much as they'll learn from you. Because true mentoring is always two-way. You learn from the people that you talk to. And if you're the mentor, they may be younger, they may not have the experience that you do, probably don't, but I take ideas from the people I mentor all the time and implement them, and I'm just so excited that I had the opportunity to talk to somebody with a different perspective. So So if you're at a company that doesn't take D&I seriously with perhaps a mentoring program, I urge people to try to make it happen at your company. Small companies have a little bit less ability to do things like that, and it may be more informal, but there's no reason that they can't do that as well. So I think that all organizations have an obligation to try to have as broad of a workforce as they can. And again, it's not that women bring more, they just bring a different perspective. If I worked in a company that was 100% women, while it might be interesting and fun some days, I don't think the company would be as good as a company that was much more balanced.
And that would go for diversity as well, right? Different cultures, different backgrounds,
exactly.
Those types of things, yeah.
And then, though, on a personal basis, for anybody, I'd say seek out organizations, women in HPC, that you're on the board of. That's an incredibly important one for this field. But there's, I remember I used to mentor and lecture for American Institute of Chemical Engineers. And they had a women's organization. And there's a Psi Mu Epsilon is a math organization that I'm part of and have been since college. And there's all sorts of organizations, no matter what your technical field is. I urge people to reach out, find a chapter near you, or just get involved virtually, and find somebody that you click with who can mentor you and give you advice. And then if you're a little bit more established in your career, whether you're mid-career or further in your career, I think that everybody should be mentoring at least a couple people, if not 3 or 4. It's so rewarding to be able to help. So like Molly, you mentioned that I cannot join SC24 this year, which I'm so disappointed at not only missing everything and meeting with our customers and hearing all the talks, giving talks myself, but also with just interacting with everybody who's excited to be at this and being in a community of so many folks focused on supercomputing. Last year, I was the moderator for a panel, and I had all educators on the panel, and we had this incredibly lively discussion at a luncheon at a restaurant about on-prem versus cloud computing and which is better. And it was hilarious. People were just laughing, and folks said as they walked out that it was the best talk they'd been to, including everything on the actual conference floor. And there was no, oh, well, let's be polite because Azure's in the cloud. There was real discussion about, like, where does cloud not help them and where is on-prem better? And I was slated to be the moderator again for that this year, and when I found out I couldn't go, we considered multiple people, and I was able to promote somebody that I mentor, that I sponsor. She's incredible. She's a PhD. She's a nuclear physicist. She lectures at Emory University, but she's earlier in her career. She hasn't had an opportunity like this, and she's going to be the moderator and get up there on stage with everybody looking at her, and that will open other doors for her. And I'm going to help her in the background, and one of our senior product group folks who's responsible for HPC and AI future capabilities will also be mentoring her to make sure she does the most bang-up job possible.
That's a great story. So I know that Azure will have a nice presence at supercomputing. When you think towards, and as we're kind of tying up this conversation, you think towards Ignite, for the users and probably most of the organizations will be splitting, who are in this space, will be splitting their people between Ignite and supercomputing. For those heading over to Ignite, what are the key sessions or places to look for the HPC team there at Ignite?
So I'd say we're going to be making some huge announcements, and people are just going to have to sit on the edge of their seat and pay attention to that. But turning your question on its head, for supercomputing, we are going to be streaming Ignite at our booth. We'll have a really well-positioned booth, and we'll be streaming Ignite the entire time, the keynotes, or the key talks. So folks, if they're wondering what's happening at Ignite and they're at supercomputing, head over to the Microsoft booth, and you'll be able to catch up on these major releases that announcements that we're going to be making. In addition, I'll be posting this week on my LinkedIn profile, as well as a lot of the Microsoft Azure HPC folks, announcements about, we're doing 2 events there. One is this panel luncheon that I talked about, and the other is with our key partner AMD, a big evening mixer. We would love to have folks contact us to attend it, where they can talk to a lot of Microsoft people, a lot of customers they can network, and there'll be a link on my LinkedIn profile, so folks can go ahead and register for those events. In addition, we'll have a full panel of us and partners speaking in our booth, and we will have a robot barista, which is really something to be seen if you haven't seen it. So
actually making the drinks.
Yes, so drop
Fun.
by the
I saw that on a
Microsoft
cruise
booth.
ship in Norway this summer. That was very cool.
Order a fabulous drink and watch a robot make it for you.
Kind of going back to our conversation about why HPC is a great field to be in, and pushing on through as a technologist in this field. The results of your work often are changing humanity, whether it's protecting against the next major storm and being able to forecast data better, or solving some of these medical issues, or making a company able to take on another project to make more money. There's a lot of really neat personal results that people can relate to that I think make HPC particularly exciting. It's not just the technology, but the work and the research that's being done.
The mission, absolutely.
All right. Well, Desiree, thank you for joining the show. It's been great to have you on as a guest, and I'm really pleased personally to get the chance to meet with you. For our audience, we'll be putting links in to the Jellyfish case study we referenced. We'll put a link to Desiree's LinkedIn profile so you can find, as she's posting the links about the events she mentioned at Supercomputing, in the show notes as well. And we look forward to having the chance to talk with you either at Ignite or at Supercomputing.
Molly, thank you. It's been a real honor.
Thanks for listening to Data Unchained, powered by Hammerspace. To learn more, visit hammerspace.com. If you have a guest you would like to hear on the show, email me at molly@hammerspace.com.